Thanks for watching. And before we get our hands dirty and solve PDEs, I want to give you a little primer or recap on how to use Laplace transforms to solve ODEs. Because this will act as our skeleton. Because solving PDEs will be the same steps but harder. So, for instance, consider y double prime minus 5y prime plus 6y equals 0 with those initial conditions. Well, the first step to solve this was take the L. The L, meaning apply Laplace transforms to both sides of the equation. So we get L of y double prime minus 5 L of y prime plus 6 L of y equals L of 0. L of 0, and the main idea or the main feature that helped us solve this was the Laplace miracle. So use Laplace miracle, which said that L of y prime was SL of y minus y of 0, which once again says the Laplace transform turns derivatives into algebra. And using that, we're able to turn this differential equation into an algebra equation. In other words, what happens to this differential equation, all it becomes is the following, namely s squared minus 5s plus 6 L of y, and then minus 4s minus 11 becomes L of 0, which is 0, and then we end up getting L of y equals to some junk. So 4s minus 11 over s squared minus 5s plus 6. So that was the first step. In other words, take our differential equation, apply the Laplace transform, and solve for L of y. The reason I'm mentioning this is because for PDEs, it will be the same thing. Start with your PDE, apply the Fourier transform, and solve for f hat. So same steps, but harder. Now, the next step was to recognize the right-hand side as a Laplace transform. So we want to figure out this 4s minus 11 over s squared minus 5s plus 6 is Laplace of what? So that was the main thing, because then we can say y is whatever that is. And in order to do that, we use partial fractions. So step 2, so partial fractions, and we wrote this as 4s minus 11 over s squared minus 5s plus 6. And if you partially fractate this, I think you get 3 over s minus 2 plus 1 over s minus 3. Now, for PDEs, we will not use partial fractions, but really the main thing to remember is we want to write this as a Laplace transform. That's what's most important. So if you recognize this as a Laplace transform, this will be Laplace of 3e to the 2t plus e to the 3t. That was the main thing. Because what will happen is we will have the right-hand side and somehow recognize this as a Fourier transform. So same steps. And the last thing is just to compare. So step 3, what did we have so far? So just compare. So we have L of y was this 4s minus 11 over s squared minus 5s plus 6. And we saw that that was Laplace transform of, I believe, 3e to the 2t plus e to the 3t. And well, since Laplace of y was Laplace of this junk, all we need to do is compare and we get our solution. So y is 3e to the 2t plus e to the 3t. So, just to summarize, there were 3 steps. One was take the L, and then we have a miracle. And solve for L. L of what? Then the second step was recognize the right-hand side, or write, if you want the right-hand side, as L of something. And then the last thing is compare. And I'm mentioning this because for PDEs it will be the same thing. We will take the Fourier transform, use the Fourier miracle, and solve for f hat. Then we will write the right-hand side as f hat of something. And lastly, we will just compare. So please keep the skeleton in mind when we'll try to solve PDEs using the Fourier transform. All right, if you like this and want to see more math, please make sure to subscribe to my channel. Thank you very much.